This short video will explain how to find ST in number 15 and how to find CD in number 16. Notice that we do know the radius of this circle. It's from the center to the edge, which is 11. Well, that means the radius is 11 everywhere. From the center to the edge will always be 11. So from the center to the edge will be 11. And now we have a right triangle. This is a right triangle, and one leg is 7, hypotenuse is 11, and the distance from the center to T we don't know, so let's call it B. Call it anything you want, we just need to find out what it is. So B and 7 and 11 in a right triangle, we can use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. That is 7 squared plus B squared equals 11 squared. Let's write that down. And then let's do the arithmetic. Let's subtract 49 from the left and from the right, because remember, algebra is just a bunch of BS, both sides. If you subtract it from the left, then you have to subtract it from the right. So that gives us 72. And now we'll take the square root of both sides. Don't forget the positive and negative for the algebraic solutions, but in this case, we'll only be dealing with the positive one. And the square root of 72 rather, is the square root of 36 times 2, which is 6 root 2. Alright, so if B is 6 root 2, then the distance from S to T will be B plus B, which will be 2 of those. And two of those is 12 root 2. And that's number 15. Alright, let's take a look at number 16. But before I do, if we read the instructions, they actually ask for the length to the nearest tenth. So we'll have to put this in our calculator and get the answer to the nearest tenth, if we're following the instructions anyway. This is exact. The exact answer is 12 root 2. If we put this in our calculator, we'll get the length to the nearest tenth, and that will be an approximation. And that is approximately, our calculator says 16.97, but if we're going to the nearest tenth, then that's only 1 decimal. So we look to the right. This is 5 or bigger, so we have to round the tenth up 1, which brings us to our final decimal approximation, 17.0. Alright, now let's take a look at number 16. It's pretty similar in that we do know the radius. Remember, we started talking about the radius of 11 here. Well, the radius here is 5 because these two segments are congruent. So 2.5 and 2.5, the radius is 5. What do we do next? We'll draw another radius, and the radius we know is 5. And this must be a right angle, so once again, we have ourselves a right triangle. And this is going to help because CD is the distance from here to here, which is this length times 2. So we can call this B again if we want, or any letter at all. And then 2.5 squared plus B squared is equal to 5 squared. So 6.25 plus B squared is 25. We'll subtract 6.25 from both sides, and that will give us B squared. Let's see, if we take away 5, we're down to 20. We need another 1, which is down to 19, and another quarter of 18.75. Alright, so taking the square root of both sides, don't forget algebraically there'll be 2 solutions, but we only want the positive one because it's a length. And we have B equals the square root of 18.75. That's the exact answer. And the decimal approximate. We need to know the distance from C to D, which is 2 B's. So CD equals 2 of these. And when we put that in our calculator, and round to the nearest tenth. That's approximately 8.7. All right. I hope that helps for problems like 15 and 16.